Oh, hey, didn't see you there. I guess it's time to make another review video for Honors Geometry, Chapter 8, Similarity. It's going to be awesome. And guess who's in attendance here? Little River Dog Jenny action. What up, Jenny? She is sleeping. Whoops, I just rotated. Oh, my goodness. What is happening? Okay, we're better. Okay, cool. All right, let's math here. Let's math now that we're done with the shenanigans. All right, find the ratio of x to y. So for this one, I need to first start by cross multiplying. So I'll have 4 times 4x plus y. Make sure that you distribute if you're doing this on the fly especially. I will have 16x plus 4y, and then I'd have the 3. So I'd have 15y plus 6x. All right. So I've distributed. We're all good there. Hopefully, again, I don't make any mistakes here. But if I do, email me. All right. So I'm going to get my x's on one side. So let's go with 10x then and subtract 4y. So I get 11y. Now, I want x to y. So that means I'm going to want to divide by y. Boom, that's gone. But I don't want that pesky 10 chilling there with that x because then it's 10x over y, not x to y. So you know what? I'll also divide by 10 at the same time. Now I'm left with x to y equals 11 to 10. Whew. Awesome. All right, next one. Find the geometric mean between 8 and 24. So if I'm trying to find the geometric mean, I'd have to set it up as 8 over x equals x over 24. Now when I multiply, cross multiply, I'm going to get x squared equals 192. Now I need a square root to solve. And we're going to leave this as a simplified radical. All right, so I'm going to have x equals, I need a factor tree this bad boy. All right, so if I start by dividing by 2, it's an option. A lot of people like to go with 2s. Then I got 96, 2 and 48, 2 and 24, 2 and 12, 2 and 6. Oh my goodness, 2 and 3. That's a lot. That's a lot of 2s there. There are some quicker ways of going about it, but this is the most systematic, consistent way. So I've got a pair of 2s. That's 2 times 2 times 2. So 2 times 2 times 2 is 8 root 3. That would be my final answer there. Woo! Woo! Good stuff. All right, time for a little solving here. We got looks like a lovely little triangle here, and a couple parallel lines. Okay, so if I see those parallel lines, that tells me I've got not only similar triangles because I have all those angle relationships, right? The corresponding angles are congruent, but I also have a possibility of side splitter theorem happening here. So if I set these up, it says here in the given, I've got AC is 10, so this whole thing is 10, and then I've got, I'm going to move this out of the way a little bit. Technology. Okay. Then I've got AB, that equals 14. All right. And now I want to find AE and DC. How about let's start with AE. I'm going to call AE X. Okay. So if AE is X, how can I set this up here? Well, it looks like I've got information about bases of these two similar triangles. So that's not going to involve side splitter theorem in that set, right? Because side splitter theorem only applies to the sides that are being split. In this case, it's AC and AB, those sides right there. But I could do, how about this? Let's go with x over 6. So I have a side of the small triangle over the base, the parallel base of the triangle. And then what's the whole side? I would have 14 over the entire base of the larger triangle. That works, right? I don't have any simplifications I can do right now. So I'm going to have to do 6 times 14, that's 84. I'm going to double check so I don't make mistakes. Yes, 84. All right, so I get 9x equals 84. I got to divide by 9. So I'll get x equals, if I divide that by 9, it's going to be a lovely decimal. 9 1/3 or 9.3 repeating, or just 84 over 9. Or 28 over 9. 28 over 3, excuse me. Okay, so any of those reduced, that's cool. All right. Now, let's see here. I also want to find DC. So I've got AE, 28 over 3. Let's say that's our final answer for that one. Improper fraction, my favorite. I hate mixed numbers, but if you wanted a mixed number, there you go. DC, let's see. Well, this one's a little tricky. I'll call DC Y, though, because that's what I want ultimately, right? Okay. So I'm dealing with the other half of the triangle here, and I could probably still use my bases, except for I don't know what AD is, and that would be the side of the triangle that I would need if I'm working with that side. So AD, could this be, how about 10 minus Y? Because whatever DC is, the whole side is 10. I'm going to subtract out whatever that Y is, right? So I could do this. 10 minus Y, which is a side of that small triangle, over its base of 6, equals, and then the entire side of that of the big triangle is 10 over the base being 9. So this is kind of a weird setup because the segment we want isn't even really like a part of the similarity statement there, of the triangles, but I can still assign it a variable, and I can keep AD, which is one of the relevant sides, in terms of Y. Now when I cross multiply and solve, my answer will be what we're asked for. So no simplifications here, but I'll have 90 minus 9Y equals 60. So negative 9Y equals negative 30. And then we're going to go ahead and divide by negative 9. And I'll get Y equals, they're both divisible by 3, so it'll be 10 over 3, so 10 thirds. Boom. So that would be my DC. Definitely a tough problem. Okay, definitely a tough problem on that one, just because it asks for a side that's not even a side of the triangle. We probably could have, now that we know, you could use side splitter theorem here and gone across, but then, actually, you know what? You even have enough. You'd have enough information because now you've solved for x, but x was a fraction. Do you really want to deal with cross multiplying with that? Not really. So I'm thinking the similar triangle route was the best way to go here. Okay. All right. A kite has side lengths in the ratio of 3 to 5. If the perimeter is 80, find the length of each side. Ooh, a ratio prop. Who would have thought, right? So a kite, let's refresh ourselves on a kite here. 2 of the sides are congruent and 2 of the sides are congruent. So if we're really drawing this up, I would say that maybe let's call this one 3x and this one 5x, right? And that would make this one also 3x and this one would also be 5x based on our properties of a kite. 2 congruent and 2 congruent, right? The consecutives. So the perimeter is 80. Well, what can I do with all these sides? Well, if I add them all up, that would be 16x equals 80. And if I divide by 16, I get x equals 5. So then when it wants each side length here, I'm going to get 25 for this one, 25 for this one, 15 up top, and 15 up top over here. Boom. It's really hard to read that 15 after I circled. There we go. It's better. There's all of our sides, right? Add them up. It's perimeter. Bingo, bango. How's that sound, Jenny? Is that pretty good? Are you enjoying the math? Okay. Jenny is most definitely enjoying the math. All right. Yay? I don't know. I should probably know that before I read it. Is standing 10 feet from a 15-foot tall lamppost. I should say tall. 15-foot tall. A light post. For an album cover photo shoot, right? Latest album. It's going to be dope. If he is 5.75 feet tall, that's 5'9". Okay, but I didn't want to put 5'9", make you do conversions and freak you out like that was going to be on the test. How long will his shadow be? Okay. Well, let's draw this one up, shall we? So we've got a light post. Boop. And it's shining bright like a diamond, right? Not Kanye, I know. Okay. And then he's what up, dude? Kanye. He is 10 feet. This one is 15 foot. Okay. And we want to know how long is his shadow going to be. Okay. So his shadow is obviously going to it's like, right? And it's going to hit somewhere over there. So we want to know what this bad boy is. Hey, this certainly looks like a similar triangle situation. Don't you think, Jenny? Don't you think, Jenny? No? Yeah? You're yawning. You're yawning in class. She's yawning in class. Would never happen in my class. Usually, Jenny. Okay. So let's set up a proportion, shall we? And we know that he's 5.75. Almost forgot. All right. So proportion. I would have, let's say, how about this? Kanye's height over his shadow equals the lamppost height over its shadow. Right? Its whole shadow is going to end at the same spot as Mr. Yi himself, if you will. If it had it was shadow, I don't know, whatever. All right, cool. So we're setting up similar triangles here, right? So if I'm doing a triangle created by Kanye himself, that's 5.75 and that length. This triangle's height is 15, but the full length is 10 plus x, okay? Now, let's cross multiply, and we'll solve. So we get 15x equals, I don't know why I decided to do 57.5 plus 5.75x. All right. And I don't want to make a mistake here. We're going to get out some calculations. All right. So we're going to have, 9.25x equals 57.5. Cool. Divide by 9.25. And we get x equals, it was 6.216, so 6.22 feet if I were to round it. Yes, decimals or fractions can occur on this one. These were obviously kind of messy numbers, but whatever. There we go. Main thing is that setup there, guys. We're using similar triangles. All right, so we got a loaded diagram here. A lot of parallel lines, everything labeled here. So I'm going to go ahead and label this diagram. We have FG is equal to 8. I'll pop an 8 there. GH is 2, HI is 4, and IJ is 6. First question is, if CE equals 16, find AC. So CE, we're saying this is 16. We want to find AC. So if I'm going to set up a proportion, I know that I'm working with the 16, and then right across from that, we have 10, okay? So what I can do is I can do 16 over 10 or 10 over 16. And then I want AC. Well, what's across from AC? That's kind of lame. Oh, well. So right across this, if I want AC, that's AC is here. 8 plus 2 is 10. That's lame. But obviously we can see here that AC is going to be 16. How about we do that one again? Okay. I'm going to change this number. I'm going to change a couple things around. I'm going to say we're going to try, how about BD is going to be 22. All right. Hopefully this is a little more exciting here instead of just that. All right. So BD is 22. Boom. Across from that is 6, right? So I've got 22 over 6. And then I want AC once again, which is this part out here. So AC, and then across from that is 10. Cool. So there's my setup. I went left to right. Okay? Now, cross multiply. So I got 220, and we're going to divide that by 6, which is a decimal. All right? So we get 6 times AC equals 220. Divide by 6. So we've got, 36.6 repeating. And I can hit math. And then if you hit math on your TI-84, the first option says frac. It'll reduce it. And you're going to end up with AC equals 110 over 3. Not too bad to reduce in your head since they're both divisible by 2. But just in case you're like, hey, what else could I possibly do? It's a quick way of doing that, especially when you're crammed for time on a test. All right, what is the ratio of CD to AD? Now, this is without any other information here. These are 2 independent questions on this one. I could ask these in 2 different ways, or in 2 separate, completely different questions. So none of the lengths from A will play into this. So B is its own thing. So for CD to AD, well, I don't even have any lengths over there, but I do know that CD would correspond to HI, so that's 4, and then AD would be 8 plus 2 plus 4, this whole thing, which is 14. So 4 to 14, which is 2 to 7. I know they're going to be proportional, so even though I don't know the lengths, they're all going to be like 4 to 14 or maybe 8 to 28, whatever, okay? But they're going to be at that ratio of 2 to 7. I just used the sides that were across from them based on my side splitter theorem. Lovely. All right, here we're given two triangles, triangle ABC and triangle XZY, and they're similar. And I'm asked to find the measure of angle X and the measure of angle Z. Okay, so let's see here. If they're similar, that means their corresponding angles are congruent. So Y corresponds to C according to the similarity statement. So that makes this guy 40. B corresponds to Z. So that makes this 100. And what do I know about all the angles of a triangle? They add up to 180. So I'm going to end up with 40 left over for these ones. So whether it asks for A, C, who knows? But I'd be able to get 40 and 100. Okay, I used my corresponding angles. Even though these were flipped over and smaller, I was able to line them up with my similarity statement. All right, so next question is, why are triangles ABC and ADE similar? Good question. Well, if I look at my sides of ADE, I've got a 2 and a 3. Now, my total sides for AB, that'd be 6, and this would be 9. So we've got some information about sides. Are my sides proportional, right? So that'd be, we'd have 2 to 6 and 3 to 9. Those both reduce down to 1/3. So that checks out. The sides that are known are proportional. So now I need another side or an angle. Well, I don't know anything about the bases here, right? DE and BC, but I do know angle A, reflexive property, boom, side, angle, side. Awesome. Now, in a parallel universe, if you will, right? Say I gave you, this was, how about 4? And then this was, let's say, 8. Now I could do 4. Wait, no, I don't want to do, 4. Never mind, that would want to be 12. There we go. 4 and 12. That would also reduce down to 1/3. So boom. Now I could say side, side, side similarity, okay? Because I have 3 sets of sides and they're proportional. Cool? Cool. Awesome. Wonderful. Jenny, how we doing? She just did a, breathe out. She's huffy puffy. All right. If triangle ABC is similar to triangle XYZ, find the perimeter of triangle XYZ if the perimeter of triangle ABC is 28. All right, so, interesting. It's all we've got are 2 sides and a perimeter. But if I do recall, we learned something pretty dope in class. If my triangles are similar, then their sides are proportional, and so are their perimeters, right? So, I could do 10. Let me change colors. 10 over 8, which would be the sides, the corresponding sides, should also set up with my perimeter. So 28 of the larger triangle, and then we'll call it X. That'll be my perimeter. So I have side length over side length equals perimeter over perimeter. I'm going to reduce this down to 5/4, and now we can cross multiply and solve. All right, so I get 5X. And then we get, what is that, 112? Just checked it on the TI-84. We're good. All right, so I get 112, and I'm going to divide that by 5. Now we'll either get 22.4, or we can just leave it as 112 over 5 that you cannot simplify. So boom, there's my perimeter of triangle XYZ. Sides are proportional, so then their perimeters are also proportional. That does not apply to area in the same way. There is some similarity aspect, but it's not linear like that. It's not the same exact thing. All right, 10 is the mean proportional. Remember, mean proportional, geometric mean, they mean the same thing. 10 is the mean proportional between 5 and what number? So I know my mean proportional now. So in my awesome proportion here, 10 is in that spot. Now, 5 is the smaller number, so I'll pop it up here, and then I've got my X. So now I've got just some cross multiplication again. My goodness. 5X equals 100. Divide by 5. Get X equals 20. There we go. That was awesome. That was a quick one. Bang. All right, given the diagram over here, we're going to find BD. I have a triangle. I've got an angle being bisected. Ooh, there is an awesome little thing that happens when our triangle has an angle that's bisected. All right, so I can set up one of two proportions here, basically as we always have. Oh, Jenny, do you have something that you were thinking about? Nope, she just got an itch. Okay, I thought she was raising her hand. All right, so I can set it up as 8 over 10 equals, and I'll call BD x. X over 7, or I can do 8 over x equals 10 over 7. I don't know if my hands are backwards with that. I don't even know if it's laggy or not. I'm sorry if it is. All right, I'm going to reduce this to 4 over 5, and now I'll cross multiply. So I get 4 times 7 is 28 equals 5x. Divide by 5, and I'm going to get, boom, and then that's just going to be 28 over 5. There we go. There's BD. Now, what if it asks for BC? Another what if. Okay, so I would do 7 plus 28 over 5. Oh, I can't do that. I can't add fractions. Yes, you can. I need a common denominator. So this is going to be 35 over 5 plus 28 over 5. All right, I multiply the 7 by 5 over 5, get my common denominator. Now I'm ready to add. I get 63 over 5. Woo! Awesome. Fantastic. Wonderful. All right, this one took a little bit of thinking here. So let's hop to it. Sound good, Jenny? Okay. All right, so I want to solve for x and y. I've got a triangle with another triangle in it, right? I got some parallel lines. Ooh, parallel lines. Side splitter theorem is possible. Similar triangles is possible. The whole world is possible here. All right, so how about, I'm going to go with, well, let's see here. If I try to solve for x first, I got to go 6 over 8 equals this whole side over 20. Or I could do 8 over x, sorry, 6 over x. 8 over x equals this whole side over 20, and I'm missing some information. So it looks like I need to solve for y in order to get x in this one, which is always a scary situation. But let's try and solve for y first. I can use side splitter. 8 over 6 equals y plus 4 over 2y minus 2. All right. Now, so I went top to bottom, right? I can reduce here to 4/3. And I'll have, let's see, that'll be 8y minus 8 equals, and that'll be 3y plus 12. So I'd have 5y equals 20, so y equals, not 40, 4. All right, so if y equals 4, halfway done. That makes this one 8. That makes this one right here 6. Ooh, look at that. It's halfway up on each side. That's like a midline. That's fun. All right, now I can set up and solve for x. So either one works. I'm going to go with, let's see here, 6 over x is equal to, then I have to do the whole side of 12 over 20. And some of you might be kind of realizing already what this is going to be because we did say it's a midline, right? So it should be half the length if you recall from the last chapter. So here I could reduce down by 4 and I can get 3 over 5. So I'm going to have 30 equals 3x. So x equals 10 as expected. Awesome. Fantastic. That is wonderful. Don't you think, Jenny? Isn't that wonderful? Passed out. Okay. I think maybe time for like one more. All right. It's time for our final problem. We're going to do a proof. I had to move so I can get a charger going. Jenny's just chilling over there. What up, Jenny? All right. So now, let's see here. I got a trapezoid. Just freaked people out on the review today in class. So I decided to bring it in, right? I got some cool down lighting. All right. Trapezoids. Big thing with trapezoids, parallel bases, right? Parallel lines get us congruent angles. So let's see here. Forgot I wanted to add one last thing to the given there. It's that all three of these are going to be parallel. So this is parallel to this, is parallel to that. Okay. So it's parallel to the two bases of the trapezoid. So it's given to us. We don't even need to state it. All right. So now, what's that going to give us here? I believe it gets us some congruent angles. Well, this angle here is corresponding to that one there with those two parallel lines, right? That's pretty cool. That's pretty cool. And I also have these two for the same reason here. Corresponding angles. It's a little more of a vertical line there, which looks a little different. So is that enough information to prove two triangles similar? Absolutely. I'm going to call this angle 1 and 2 for ease, and this is going to be 3 and 4. So I'd have angle 1 is congruent to angle 2, and I have 3 is congruent to angle 4. If parallel lines, then corresponding angles are congruent. Throwback. And then we have our proof statement. Triangle CGF is similar to triangle CAB. Angle, similarity. That's awesome. That's some good stuff. All right, I'm thinking I might whip up one more with this actual particular diagram, but maybe with slightly different information. So give me a moment. Actually, it won't even seem like any time because I can just pause the video. You know what? I decided it wasn't really working in my head how I thought it was going to work when I put it down on paper. So just one last final problem. Does that sound good to you, Jenny? She's back asleep. She's back asleep. Okay, Jenny, we're going to do one more problem. Then we'll go outside. All right. So I got a separate proportion here. Well, I've got a similarity statement, which helps, right? ABC is similar to EDC. So if I can kind of twist things around in my head, set it up, that's cool. If not, I can always double check with my similarity statement. Well, I know that AC here and CE, AC are the outside two, EC are the outside two. Those two are corresponding sides. So I can set up 10 over 6. Now, if I want DE, DE matches up with AB in my similarity statement, right? So that would mean that 12 over DE. DE and AB match up. The 7's not even used here. I'm going to cross multiply and solve, but first I'm going to reduce this down to 5/3. So I'm going to get 5 times DE equals 36. Divide by 5. That's left as a fraction here. So we got 36 fifths. 36 fifths. I don't know what I'm saying. All right, man. It's tired. I'm tired. It's 6:18. I don't want to do any. I'm done with math for today. All right. So you guys have a wonderful day. I hope you enjoyed it. America Freedom, rock and roll, Costco, River Dog Jenny on the gram, chilling over there, sleeping. She just wants to go outside. Yo-ro. And you guys have a great day. Okay. Have a great day. Good luck studying.